Welcome back. How did you go with the exercise with number of products? It wasn't difficult, was it? Here is the result that I got. And here you can see right away a couple of things. First of all, there are a few anomalies. So you would expect that as the number of products increases, the customer is more likely to stay with the bank. So in banking, the term I think is called stickiness, or the share of the wallet of the customer. So as the bank has a greater share of the wallet, it is harder for the customer to leave. And that is what we are observing in the first two. So people who have two products with the bank are less likely to exit than people who have one product. In fact, as you can see, we can't see the labels here because the font is too big. So why don't we just take out the text label for now for our analysis, and that way we'll see all of the labels. So here you can see that only 8% of customers with two products left and 28% of customers with one product left. So the massive drop, it is much harder for these customers to leave. But then we see an anomaly here. So we see how as you get more products, so 3 and 4 products, it is customers are leaving at a rapid rate, at a very, very high rate, 83% and 100% at 4 products, which does not align with our intuition whatsoever. So those are massive anomalies, or very distinct anomalies, and we need to understand what we can do about them. So the first thing that comes to mind, and the first thing that you should always remember when you have anomalies that great, there might be something wrong with the data, or not wrong with data. It just might be a insignificant result. That's what I'm looking for here. It might be an insignificant result, and therefore it might not be worth reporting. What if there are only 5 people that have 4 products, or if because this is a large sample, it's 10,000 people together. What if there's like only 100 people that had 4 products, and they all just happen to leave? So it's kind of like a random effect rather than something that you can rely on. And that is why we have to be cautious that these tests that we're doing, they're not statistically full-fledged statistical tests. They're more ad hoc visual tests. So in these cases, we would need to check the actual number of people. So now I'm going to show you how to do that. And in order to check the number of people that left, we'll talk more about this kind of approach, or a more thorough approach on this in the next section of the course. But for now, I'll just show you a quick way to do it. So I'm going to take the number of records over here, and I'm going to drag a number of records into label just as a text. So rather than doing a table calculation, I'm just dragging it as it is. And so here you can see, now we will just take out the table calculation for now, because once again we can't see what's in there. So here what you'll see is that these two categories, they have quite a lot of people in these categories, but these categories, they have fewer people in the categories. So there's only 266 people with 3 products. There's only 60 people with 4 products. So that can possibly explain why we're seeing this anomaly. It just happens that the sample that we randomly selected, among them, all the people that had 4 products, they were at very high risk of leaving, and they actually did leave over the observed period of time. So sometimes when things like this happen, you have to investigate further, and you have to conduct proper statistical tests to make sure that these results are valid. So in this case, you can say that going from 1 product to 2 products, it's harder for people to leave. For 3 and 4 products, you would need to investigate this further. So that's what I wanted to show you with this chart. We will return it back to its previous state now. And maybe you want to add a comment for yourself here, so that in the future you remember that there's some investigation to do. So you go annotate, and then you just select area, for instance, and here you want to say something like low observations in the last 2 categories. So just a label for yourself. So we're not going to go into the details of these investigations. Our goal is to understand how to work with Tableau, but nevertheless, you want to have some information for the future. So there you go. I just added a label. So whenever I go back to this chart, I'll be able to see that there's a low number of observations in these categories, and I need to do something about it. So that's all for this chart. What I wanted to show you today is how to validate your approach and in fact validate your data. So let's go ahead and create another test. I'm going to duplicate this one over here. So duplicate sheet, and this one we'll call validation. And we can get rid of this comment. So the idea here is to find a variable that you know for sure does not affect your end result. So something that is definitely not a important variable in the choice of customers to stay with the bank or exit the bank. And a good variable here would be a number. So like a digit, 1-digit number. So if say the my favorite is if the customers, if you have mobile phones in the data, you can just take say the last digit of the mobile phone. Or in this case, we have customer ID. So let's take the last digit of the customer ID. As you can imagine, it has nothing to do with whether or not the customer will leave the bank. It's not a predictor. It doesn't matter what last digit. In fact, it doesn't matter what customer ID you have at all in terms of your decision for staying or leaving the bank. And so once we run the test for the last digit of the customer ID, we can then check that, yes, everything is fine. It has to be all of the last digits have to have the same probability of leaving. So let's go ahead and check that. We're going to right-click customer ID and we're going to create a calculated field. Haven't done one of these in a while, have we? So we're going to say last digit of customer ID, and here we're just going to say right, as in the last character. 1, and as from here you can see that table calculation is not correct. That's because customer ID is still deemed as a number. We need to change it to a string, so we'll just say str and we'll close the brackets there. So that looks good, and now we have a new variable here, last digit of customer ID. As you can see, it's a calculated variable, and we can take this and replace number of products. Let's go ahead and do that. And so right away, you can see a beautiful, very uniform picture here that approximately on average, every customer ID that you have, or the last digit of the customer ID, it has the same, people with that digit have the same probability of leaving as average, about 20%. So plus or minus, some fluctuations exist always in your data, but in this case, it's plus or minus a little tiny bit, which is insignificant. So on average, it's 20%. So that's how you check your data. Another way you could do it is you could look at the last or first letter of the customer surname, but that is a bit more tricky because letters are generally less uniformly distributed. They're not as randomly, so you'll find that letters like Q are rarer, letters like T are more frequent, and that can affect your results. So try to find something that is uniformly distributed across your population or your sample, and at the same time it does not affect the end outcome at all whatsoever. And that will allow you to validate two things. First of all, our approach. Now we can see that our approach is valid, because if it wasn't, or if we did see some skewness here, then maybe we would question our approach. And also we can see that the data is, there are no errors or issues with the data, because let's say if we saw that one or a couple of these is too high, then that would mean that perhaps maybe there's some problems with the data. Why is there this observation, this anomaly that shouldn't be there? And that's the end of this tutorial. You can come up with other similar ways to validate your data, and I encourage you to use them just to make sure that along the way, while you're doing your analysis, everything is running smoothly. I look forward to seeing you next time, and until then, happy analyzing.